The Antonio Project presents Chapter 1 Water Fundamentals. Hello everyone, see you back in my channel. At this time, we begin Chapter 1 Water Fundamentals, the foundation for understanding boilers, steam system, and marine engineering operations. In this chapter, we will learn molecule structure of water, state of matter, and the properties of water. Water might look simple, but it has unique properties that make steam power possible in ships, industry, and power plants around the world. So, whether you are a marine engineering professional seafarer or engineering enthusiast, this series will help strengthen your understanding of steam engineering from the basics. Let's get started with Chapter 1 Water Fundamentals. Let's go! Molecule structure of water. Water is one of the most important substances on Earth. It covers about 70% of the planet's surface and is essential for all living organisms. Humans, animals, and plants all depend on water for survival. Without water, life would not exist. Water is used for drinking, agriculture, transportation, industry, and power generation. Because of its importance, water is often called the source of life. Let's find out the structure of water is, its chemical configuration, and its atoms. Following is the periodical table of the elements, a table of the organized array of all the chemical elements in order of increasing atomic number. A molecule of water is composed of two atoms of hydrogen and one atom of oxygen. Hydrogen atom, atomic number 1, proton 1, neutron 1, electron 1, 1 electron in the cell. Oxygen atom, atomic number 8, proton 8, neutron 8, electron 8, 2 electrons at inner cell and 6 electrons at outer cell. The octet rule states that atoms combine in such a way that each atom gains 8 electrons in its outermost or valence cells, similar to the configuration of a noble gas. For details, please watch my previous video about noble gases. Atoms are more stable when their outer shell is full, or 8 electrons. To achieve this state, atoms will either 1. Share electrons, known as covalent bonding, or 2. Lose or gain electrons, known as ionic bonding. The oxygen atom attracts the shared electrons of the covalent bonds to a significantly greater extent than the hydrogen atoms. As a result, the oxygen atom acquires a partial negative charge, while the hydrogen atoms each acquire a partial positive charge. The molecule adopts a band structure because of the two lone pairs of electrons on the oxygen atom. The bond angle is about 104.45 degrees, slightly smaller than the ideal of an hybridized atomic orbital. The chemical name of water is dihydrogen monoxide or H2O, although the International Union of Pure and Applied Chemistry or IUPAC formally recognizes oxygen as its systematic name. Polar molecule is a molecule that has an even distribution of electrical charge, resulting in a positive end and negative end, or a dipole. A hydrogen bond is the attractive force between a covalently bonded hydrogen atom and a highly electronegative atom, such as fluorine, oxygen, nitrogen, and another electronegative atom. State of matter. Water, or H2O, is a remarkable substance that exists in three primary states: solid, liquid, and gaseous. Each form exhibits unique characteristics and plays a crucial role in the Earth's ecosystems and human activities. Water exists in three main states of matter depending on temperature and pressure. These different states of matter have different properties and characteristics. The following is the states of water and their characteristics. Solid state. In the solid state, water is called ice. This occurs when water freezes at temperature below 0 degrees Celsius or 32 degrees Fahrenheit under normal atmospheric pressure. Characteristic of ice has a fixed shape and fixed volume. Molecules are closely packaged. Ice is less dense than liquid water. More space between molecules compared to liquid water, which is why ice floats. In ice, water molecules are arranged in a fixed crystalline structure. The molecules are held together by strong hydrogen bonds. Molecules vibrate, but do not move freely with regular hexagonal arrangement. Because of this open structure, as the water molecules are being held further apart, the volume of water when freezing increases about 9%. So, molecules are more tightly packed in water's liquid state than its solid state. Liquid state. In the liquid state, water flows freely and takes the shape of its container. This is the most common form of water on Earth. Characteristics of liquid water has fixed volume but no fixed shape. Molecules can move freely. In liquid water, molecules are still connected by hydrogen bonds, but the bonds continuously break and reform. Molecules are close together, no fixed arrangement, moderate intermolecular attraction. Each water molecule links to four others, creating a tetrahedral arrangement. However, they are able to move freely and slide past each other, while S form a solid, larger hexagonal structure. Gas state, steam or water vapor form. In the gaseous state, water becomes steam or water vapor. This happens when water boils at 100 degrees Celsius or 212 degrees Fahrenheit under normal atmospheric pressure. Characteristics of steam. In steam, water molecules are far apart and move freely at high speed. No fixed shape or volume. Molecules move very rapidly. Can expand and fill any space. Very weak intermolecular forces. Large distance between molecules. Random motion in all directions. Change between states. Water changes from one state to another through heating or cooling. Melting from ice to water. Freezing from water to ice. Evaporation or boiling from water to steam. Condensation from steam to water. Properties of water. Water is a unique substance with essential properties that make it vital for life, including its high specific heat, density behavior, and solvent capabilities. Following is the several properties of water. State of matter. Water is the only common substance that exists naturally in all three states: solid, liquid, and gas at Earth's surface condition. Density of water is the mass of water contained in a unit volume. It shows how closely water molecules are packed together. Ice. Melting point is 0 degrees Celsius with density of 0.917 gram per square centimeter, which is unusual because most substances are denser in their solid state. This property causes ice to float on liquid water. Water, the density is 0.977 gram per square centimeter. The maximum density of water is 1 gram per square centimeter at 3.98 degrees Celsius. Gas, the boiling point is 100 degrees Celsius and density is 0.6 gram per square centimeter. Water has a high specific heat of 4186 joule per gram degree Celsius at 20 degrees Celsius and high heat of evaporation because of hydrogen bonding. This allows bodies of water to have minimal fluctuations in temperature to regulate climate. Cohesion and adhesion. Hydrogen bonds between water molecules are constantly breaking and reforming with other water molecules. Cohesion is the ability of water molecules to stick together. Water's polarity also gives water high adhesion, or the ability to stick to other surfaces. The adhesive forces are stronger than cohesive force. Strong cohesion and adhesion cause water to exhibit capillary action. Capillary action is the process of liquid flowing through a narrow space without and often against gravity. Surface tension. The hydrogen bonding also causes water to have a high surface tension of 0.072 joule square meter. The surface tension is high enough for insects to walk on water. Surface tension is a result of water's cohesive properties. Water droplets and water rising above the rim of a glass show water's high surface tension. Global solvent. Water is the solvent of life. Hydrophilic substances are those that dissolve in water, while hydrophobic substances do not mix well with water. Substances can dissolve in water if they can match or overcome the hydrogen bonding between water molecules. If they cannot, the substance forms a precipitate. Water is amphoteric, meaning it can act as either an acid or base, depending on the solution. It can produce both H plus and OH means ions. Water is a polar molecule because it has an even distribution of electrical charge due to the asymmetric shape. Dipole moment of water. The dipole moment is the measure of separation between positive and negative charge in a molecule. Dipole moment approximately 1.855 debye. The net dipole moment is the overall dipole effect of a molecule after adding all individual bonds dipoles as vectors. That concludes chapter 1, Water Fundamentals. Today, we discuss about the basic properties of water, molecular structure, state of matter, and characteristics of water. This fundamental is very important because understanding water behavior is the first step to understanding boilers, steam system, and thermal engineering. I hope this discussion helps you with a stronger foundation in steam engineering and marine engineering knowledge. Thank you for watching. Don't forget to like, share, and subscribe. For the next chapter, we will continue exploring the world of steam and boiler engineering. See you in the next chapter. Bye bye. If you have any question or suggestion, please leave your comment below. Feel free to let me know if you see anything that needs adjusting. Your subscription will give me more views to run my channel.
Thank you for watching my video. Terima kasih. I Antonio Project.